Hello, so today we are going to do this problem called convert sorted array into binary search tree. So the problem says we have an array of integers, numbers, and the elements are sorted in increasing order, and we want to convert it to a height balanced binary search tree. So what do they mean by height balanced? Basically, it's just a binary tree where the depth of the two subtrees of every node, so the two subtree children of every node, never differ by more than one. So at most they differ by one. Okay? So basically kind of something like this. If you take here where they have the same height, here also have the same height. Yeah, so that's the idea. So if we take a look at the example here, this binary tree here, binary search tree, we have this array, and so the easiest thing to do to make sure it's height balanced is to pick the middle and make it the root, and then make the rest, the left side its left child and the right side its right child, and then we can recurse on this subarray, right, and just also do the same thing. So that's the first idea that comes to mind, and it should work both also in this example. So if you take a look at the example 2 here, yeah, this one is a little bit smaller, but what this example tells us is that it doesn't matter if you have just two elements. It doesn't matter if you pick any one of them to be the root, right? Yeah, so that's pretty much the problem. Now let's see how we can solve it. Okay, so how can we solve this? So the idea we saw earlier, because we want to make it balanced, right, is to pick just the middle and make it the root, and every time do that. So what this would mean is, for example, in this case here, the middle will be here. So what we can do is just pick that to be the root. So we'd have our root to be 0. And then make its left child be this subtree we construct from here. So this would be the left, and this would be the right side. Okay? And so here we would pick the mid again. Since it's two element, it doesn't matter which one you pick. So the middle would be, to calculate it, is just the length of the whatever the array input we have. So in this case, it's just 2 divided by 2. So it would be 1. So we would choose, let's say, -3. So we'd make that the root, and then on the left side would be this, and the right side would be an empty list. So already we know our base case would be if the list is empty, so the length is equal to 0. Okay, so in that case, what should we return? Well, there is nothing to construct, so we just return none. Now, if it's just one element, there is no need to do left or right. We could just return the node, right? Or we can let it go to the left and find out that it's 0 on the left side, and then 0 on the right side, and we will return none, right? And so, but we will construct the root, right, to be -10, and then the left side would be none, and the right side would be none. Similar thing here, the right side would make it the root be 5 and 9. That's, as we said here, 2 divided by 2, that's 1, so let's pick 9. And then we do the same thing on the subarray for the left side, which is 5, and so we add 5 here, right? Now, one thing with the recursion here is we will need to create, so we would have the mid. From the mid, we will need to create the tree node, right? So we'd have our node equal to tree node, and we'll need to put the value at mid, right? So, and then for node.left, we need to recurse on the left side. So we call our function, let's call it maybe DFS, right? And then we would have, or actually maybe let's just call it recurse. Okay, and then we would pass just the array from 0 to mid. That's what we did here. So when we are at, let's say when we are at -10, -3, 0, 5, 9, and we choose mid to be here, the left array that we are going to assign for the left side, that's just mid -1, 0, right? Whatever the start was. And then here mid plus 1 to the end, right? So here we need to pass the numbers array from 0 to mid minus 1 for the left side. For the right side, we just recurse on from mid plus 1 to the end. So that would be recurse on the numbers from mid plus 1 to the end. And you can do n, or you could just in Python leave it like that. Okay, and then at the end we can just return a node. So that's the general structure, but let's write it and make sure it passes test cases. Okay, so here's the code that we saw the idea in the overview. So pretty much just have this recursive function where we pass the array, and then each time if the length is 0, that means we are done. Otherwise, pick the middle, make it the root node. Recurse on the left side, which is from 0 to the mid, and then recurse on the right side, which is from mid plus 1 to n. So one thing we said in the overview is that this is actually from 0 to mid minus 1. But that's actually what this is doing, because in Python, if you want to add at mid minus 1 is the last element, you need the ending of the interval to be mid. And similar thing here for n, the last element is n minus 1, and so we put n. And yeah, that's pretty much it. So we assign the left portion to the left side, the right portion to the right side, and then we return the node. That way, each time we recurse, we return the root node to the parent, and the parent will attach it to either its left or right side. You could also just decide to pass the start and the end of the interval to the recursive function. That's also valid. So you would pass here start and mid, and here start and mid minus 1, and here you would pass mid plus 1 and end. Yeah, so that's now in terms of time complexity, you can see here we go through the entire array where we go through each element once. So we assign each element to the node once, right? So overall, that means we'll do at most O(n) time. Yeah, so that's pretty much it, I think, for this problem. Please like and subscribe, and see you on the next one. Bye.